Chapter 10, Sample Problem Number 6. 6 small brass and aluminum spheres are connected by 3 stiff, lightweight rods to form a rigid object shaped like a jack. The rods are joined at their centers, are mutually perpendicular, and lie along the axes of the coordinate system shown. All spheres are the same distance from the connection point of the 3 rods at the origin of the axes. The brass spheres are shaded in the diagram and are identical. The aluminum spheres are identical, but have less mass than the black spheres and are unshaded in the diagram. For this problem, ignore the mass of the connecting rods. So, as a really quick thing, we have that these are brass and these are aluminum, and the shaded mass is more than the unshaded mass. Rank the moment of inertia about the x-axis. So we're going to spin about this axis. So, for instance, in case A, we immediately see that the 2 shaded guys do not contribute because their distance is 0. So we have just the four unshaded guys. They're each at a distance of 1 away, and we'll call them mass 1 because it can't matter that much. So this is 4 masses at 1, or 4 squared. If we look at case B, the distance of everybody is the same, but B has something more than 4. Let's pretend these are each like 2 masses, which is excessive, but should be fine. And we see that we'd have something like 2 times 2 times 1 squared plus 2 times 1 squared. Anyway, we can definitely see that that B is more than A because there's more mass off axis. And again, the guys on the x-axis don't matter, so then they could have left them out, it didn't matter. We can see that C has to be the same as B because the arrangement is the same. In fact, if we just give this a quarter rotation, it would be the same picture. So B and C are actually the same device. And then D has to be more than all of them because now we have lots of mass. Right? Each of these is more than these. And 2 of them are more than these. And so since their distances are all the same, it's only the mass that's going to matter. And we have the most mass in D. We have the same mass in B and C, and the least mass in A.